Hello and welcome back. So in the last video, we saw how to display the sweep time and also some of the math functions. In this video, I would want to switch your attention to broadband signal analysis. In all the previous videos, I was using a 70 GHz VectorStar. But now on the screen, what you are seeing is basically a broadband VNA that can sweep from 70 kHz right up to 125 GHz. This unit is loaded with option 31, which is dual source. And I would like to show you some of the additional functionality of the software with dual source. So quickly jumping into the application side, we switch modes to spectrum analysis. And by default, as I mentioned, B2/1 is always configured. We are into the SPA VNA mode. For jumping into broadband analysis, we definitely need to make some changes. But as you can see from here, we have two sources, source 1 and source 2. First, we have to configure the VNA in broadband fashion. In fact, before that, to show additional functionality, let's configure to have two channels, and let's convert the second channel into spectrum analysis as well. We will configure the second channel, the receiver to be B4, that is port 4 will act as the receiver. Port 1 and 3 will act as source 1 and source 2, and port 2 and 4 will act as receivers. So in that case, to configure things properly, we need to have B4/1 for the second channel with port 3 as driving. Once that is done, at least our display is properly configured. Let's now configure channel 1 and channel 2 for spectrum analysis. So for trace 1, as you can see, let's make source 1 active. Again, I'm using the internal sources. It's not mandatory to use an internal source. An external source could be used, but for showing the functionality of the VNA acting as two tracking generators, I'm choosing 81 GHz as the source frequency coming from port 1. And before that, we actually have to tell the software that it's a broadband VNA. And now on the receiver, we can configure 81 GHz as the center frequency with a span of 1 MHz. I will enable automatic IF gain and spur reduction to have a clear and clean signal. If I hit done, you will see that automatically the configuration happens at 81 GHz. So port 1 is outputting a signal at 81 GHz and port 2 is acting as the receiver. Similarly, we can go into the spectrum setting for channel 2, again making it to 125 gigahertz. And this time I will actually activate source 2 at say another frequency. Let's pick 94 gigahertz. And likewise on the receiver side, let's put 94 gigahertz as the center frequency and a span of 1 megahertz. I enable the automatic IF gain and the spur reduction. And if I hit done, I should be seeing a signal at 94 gigahertz. So this ways, you are actually configuring two tracking generators, and you can maybe test two devices. The other thing to notice when I enable both the sources, for example, you can see the moment I activate both the sources, the dual drive ports gets activated. Let me show you clearly. If this is inactive, you will see that this area is grayed out. But the moment I activate on a single channel or trace both the sources, we have a dual drive port available. So we can drive basically from both the ports, like port 1 and 3 or 2 and 4, 2 and 3 and 1 and 4 simultaneously. This is very important for true differential measurements, wherein the phase coming out from port 1 and port 3 or various combination can be controlled. So now we can apply the same things by going into the averaging menu. I can average this per sweep and say 20 sweeps in this case. And for the other channel, I could do a smoothing functionality on, and maybe 5% smoothing can be applied. So this is how a broadband spectrum analyzer can also be configured. It's not only available for Anritsu millimeter wave modules and broadband analysis up to 220 gigahertz, but it's also available in banded configuration if the customers are using VDI or OML millimeter wave modules. In the next video, I would like to throw some light on some additional features for Spectrum Analyzer. Thank you for watching.